Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Today we will discuss about alternating current. This is the last chapter before midterm test. Okay. As you know that we have discussing about the three passive component before. Okay. Yeah, three. Okay, three passive component. The first is a resistor, and then inductor, and also the capacitor. Okay. In RC and RL circuit, it means that the series of resistor and capacitor, and also the series of resistor and inductor, the charge, the key charge, the currents I and V, the potential difference, grow and decay exponentially. And then on the contrary, in a LC circuit, the charge, current, and potential difference vary sinusoidally with the period of t and angular frequency is omega. So there is a two mechanism in the series circuit. The first, if we connect C capacitor and inductor with the resistor, so the charge, current, and the potential will grow and decay exponentially. It means that because of the resistor is they absorb the current or the charge and then convert it as a heat. So the current, the charge, and potential decay exponentially. But in LC circuits, because the inductor and the capacitor can store a charge, inductor can store a charge in magnetic fields, and the capacitor can store a charge in electric fields. So the charge, current, and potential difference will be stored in inductor and in the capacitor. So the charge, current, and also the potential difference or phi, it will become another sinusoidal current or charge on potential with a period of t. We will see later. So the resulting oscillation of the capacitor electric fields and also the inductor magnetic fields are said to be electromagnetic oscillation. So because of the charge, the current and also the potential difference is very sinusoidally with a period of t and also the angular frequency is omega. So we can say that this is like oscillation. And then what is the oscillation? This is the electromagnetic oscillations. We can see in this figure that the energy stored in the electric field or the capacitor, we can say like this ones. UE is equal to Q quadrat per 2C, where Q is the charge on the capacitor. And also the energy stored in the magnetic field or inductor must be these ones. UB is equal to Li quadrat per 2, where I is the current through the inductor at the time. So because of every kind of this passive component, inductor and also the capacitor can store a charge or store an energy, so the energy shifts back and forth from one type of stored energy to the other, but the total amount is conserved, like this one. So if we connect the inductor and also capacitor in one circuit like this one, is series like these ones. So the energy will store the first is like this one. This is the if we connect the inductor and capacitor at the beginning of the calculations, and then the I is equal to 0, but in that time the charge is stored in the capacitor, and then because of the full charge, the capacitor is full charge, so it will be discharged or transfer the charge or transfer the currents through the inductor, like we can see in the figure B, like this ones, until the current in or the charge is stored in the inductor in the maximum value, or in this kind, or in this situation, the UB is equal to UE until the charge is stored all in the inductor, like so. UB is maximum and the UE is equal to 0, and then after the UB is equal to and maximum, and it will be transferred again to the current or the charge to the capacitor, because in the capacitor now the energy is 0, so it will be transferred again to the capacitor in D, so the UB is equal to UE until the energy or charge stored in the capacitor in the maximum value, so UE is maximum and UB is equal to 0. And then you can see in this one, because the currents transfer is in opposite direction, because you can see in figure D that the current is flow in counterclockwise from the inductor to capacitor, so the positive charge and negative charge of the capacitor will change like this one, so compared to the figure A, so it's like in the opposite directions. So after the energy stored in the capacitor in maximum value, so it will be transferred again to inductor, so UE is equal to UB until UB is maximum, and then it will be transfer again the energy in the inductor to the capacitor, and then we can see this flow like this one from A to H. So because the energy from the capacitor to inductor is like a shift from inductor to capacitor to inductor, so we can see that the current and also the voltage in the inductor and the capacitor is like a sinusoidal, like this ones. And then so we can see that the voltage of the voltage in the capacitor will be determined by these equations. Vc is equal to 1 over C dot key, and then if we connect inductor like this ones, so this is we discussing before, and then if we insert like a resistor in the circuit, so we can see or we can measure the voltage of the resistor by I dot R. So this is the voltage of the resistor. And then if we insert the resistor in this circuit, small resistor, like for example, I put the resistor here and then connect to this node, so it will be absorb the energy in the capacitor and inductor. So we can see that the oscillation, the electromagnetic oscillation before, if we only connect like ideally from inductor and capacitor, we can get like a pure sinusoidal like this one. But if we connect smaller resistor in the circuits, so the voltage or the current will be decay, because the energy is dissipated in the resistor as a thermal energy. So resistor convert the energy from capacitor and inductor to the thermal energy, so it will be decay like this one. And then we can make an analogy between the oscillating LC system and also the block spring system like this one. Maybe you will learn about the mechanical physics in next semester, but in this chapter the author of the book is make analogy between the LC system and also a block spring, because of in the book they discuss about the mechanical, and then after finishing about the mechanical physics, they start to discussing about the electrical physics. So in our textbook, they make analogy between the LC system and a block spring system. But I think you are familiar with the block spring system in senior high school. Yeah, I think you have studied about the block spring system. So if the key or the charge is corresponding to x, and then x is mean this uh, x is the distance, and then the I is corresponding to v is a velocity, and then 1 per c is corresponding to k, and then the L is corresponding to m this means. So like we have the block spring system like this one. This is the spring, and then this is the block. The spring has the potential of a half of k x quadrats, and then the block have the energy kinetic of a half of mv quadrats, and then the v or the velocity is dx per dt. And then the LC oscillator, the capacitor is a half of 1 per c dot k quadrat. So the k is corresponding to 1 over c, and then inductor stored energy like for the magnetic is a half of Li quadrat, and then the I is equal to the k per dt. So the angular frequency or oscillation of the ideal of resistanceless LC is 1 over LC. So this one you can see that to calculate the angular frequency of sinusoidal energy transfer from inductor to capacitor is using this equation. Omega is equal to 1 over square of LC. And then if we use the block spring oscillator, the total of U or energy is equal to UB plus US, or energy in block plus energy in spring, or potential energy. This is the potential energy, and this is the kinetic energy. And then if we make a differential of the total energy, the U per dt is equal to d of this equation. So we can get that mv dv per dt plus kx dx per dt is equal to 0. And then if we, because of v is equal to the x per dt, so we can make this equation using the dx, so we can get this one, m d quadrat x per dt quadrat plus kx is equal to 0. And then the x is equal to x cosinus omega t plus c. And then in LC oscillator, the total U is magnetic energy plus electric energy. So this is from inductor and this is from capacitor. The energy in the inductor is Li quadrat per 2, and then energy in capacitor is K quadrat per 2C. So if we make a differential of total of energy of this one, so we can get this equation. Li di per dt plus K per C dk per dt is equal to 0. Because of I is equal to dk per dt, so we can make this equation di per dt using the quadrat K per dt quadrat. So we can get from this equation by this equation L d quadrat K per dt quadrat plus 1 over C K is equal to 0. And then the key is the big key cosinus omega t plus c as charge, and then the current I is the key per dt is equal to, we make a differential of this equation, the minus omega key sin omega t plus c, and then the I is omega key, so the I, big I, or the magnitude of current is omega key, and then the I is equal to minus I sin omega t plus c. And then this is the angular frequency. As we know that this one, E is equal to dq per dt is minus omega k sin omega t plus c. So if we make the second differential of this equation, so we can get this one, minus omega quadrat k cosinus omega t plus c. But the first question, this one, as the expression is L d quadrat k per dt quadrat plus 1 over c k is equal to 0. So we can replace this equation by this equation. So we can get these equations. L minus L omega quadrat k cosinus omega t plus c plus 1 over c kali k. K is this one. K is this one, so we can use this equation. K cosinus omega t plus c is equal to 0, and then omega is equal to 1 over square LC. Okay, and then this is the energy stored in LC circuits. We have two energy. The first one is the electric energy stored in capacitor. UE is equal to k quadrat per 2c, or equal to k quadrat per 2c cosinus quadrat omega t plus c. And then the magnetic energy is UB, stored in inductor, is a half of Li quadrat is equal to a half of L omega quadrat k quadrat sin quadrat omega t plus c. We have discussed this before. So the omega is this one, and then UB, UB is equal to k quadrat per 2c sin quadrat omega t plus c. Okay, yeah, from this one is a half of L omega quadrats. Okay, so we can make another expressions. Rather than we using the omega, we can transfer it to k quadrat per 2c, so we can get a UB like this one. And then as we know that before, the energy, total energy is stored between the inductor and capacitor. So if we make a graphic of the UB and UE like this ones, so the blue one is UE and green one is UB. We can see that if the UE in maximum value, the UB in minimum value, and we can get in the middle. This is, it means that the UE is equal to UB. And then after the energy in UB energy in UB is transferred to UB, and then UB is maximum value and UE is equal to 0, and then like this one. So we can make like a sinusoidal like this one. So the maximum value of UA and UB is equal to k quadrat per 2c, and then at any instant and everywhere, the sum of UA and UB must be k quadrat per 2c. This is like, it is constant. When UA is maximum, UB is 0. When UB is maximum, the UE is 0, like this ones. Okay, and then if we connect the small r like this one, so the r will be convert the energy from the inductor as the UB, and the UE from the capacitor become the thermal, like the heat. So it will be decreasing the energy until we can see before that it will, the sinusoidal current or sinusoidal voltage will be decay. Okay, so like this one, if we didn't put the resistor in the LC circuit, so we can get the total energy like this ones. So if we put the resistor in the series of LC, so we can get this one, that Li du per dt is equal to Li di per dt plus k per c dk per dt is equal to minus e quadrat r. So if we replacing the di because of I is the key per dt, so we can replace this expression by these expressions. L d quadrat key per dt quadrat plus R d key per dt plus 1 over c key is equal to 0. And then we know that the key is equation, this one, key, small key is key E minus RT per 2L cosinus omega accent T plus C, where omega accent is equal to square of omega quadrat minus R per 2L quadrats, and omega is like this ones. And then we can say before that UI is this ones, Q quadrat per 2C E minus RT per L cosinus quadrat omega accent T plus C. So the resistor will be, this resistor will be convert or absorb the energy from the inductor and capacitor, so the current or charge will be decay. And then you know that we have the direct current and alternating currents, and you can see that before, if we connect the L and C, inductor and capacitor, and one of them, the first is store energy, so we can make like alternating current or AC current. AC current is mean that the current situation will be like sinusoidal, so it is like maximum, minimum, and zero. So this is the AC, and we use the AC current in our home, and in industry we can use the AC current. But another current form is DC current. DC current is mean that like as constant currents. So it's like this is the I, this is the T, this is the I, and also this is the T. So it's mean that the DC current in everywhere, every time, the current or the voltage will be constant. So this is the DC current. And then we can produce the AC current by using, yes, like say that we like a PLTA in Indonesia, or PLTU. So using the energy from the water or energy from the gas, we can transfer it to to electric energy. So that after the transfer to electric energy, we have to save like in the battery, or we save in the small in the big capacitor. So the alternating current, there is a two it's like the DC current. We have the voltage and also the current. For the voltage is, we can see this one, the voltage of the AC current E is equal to Em sin omega dt. And then this is the current I is equal to I sin omega dt plus C. This is the big I and big Em. It means that this is the maximum value of the sinusoidal current or sinusoidal voltage. And then omega d is equal to driving angular frequencies. Like in Indonesia, the omega t is 60 hertz, and also in another country they using the 50 hertz. This is the angular frequency of the current or the voltage in our daily life. Okay, so if we have the E, the voltage source like this one, and then connect to R, C, and L, so the current will be flow in the circuits by I, and then will be absorbed in capacitor, and capacitor will be absorb the charge until the maximum value, maximum charge in the capacitor, and then the capacitor will be deliver the current to the circuits. And also similar in the inductor. Inductor will be store the current, and also will be save the current, and then it will be deliver until if the current in the inductor in the maximum value. It's like this one. So we have the UE here and then UB here. This is the energy stored in the capacitor and also energy stored in inductor. So if the resistor connect to the alternating current generator or source of the current, this is the AC, like this one. So this notation is mean that this is the AC. And then if you know like this equation, this is the DC. The AC current is mean that there is a sinusoidal waveform, and DC is this constant waveform. So if we connect the resistor in this alternating current generator of source of the current, so as you know that the Kirchhoff law that total of the voltage in the closed loop is equal to 0. So E minus VR is the voltage in the resistor, is equal to 0. So VR is equal to E, and then E, before we say that E is equal to EM sin omega t dt. So we can get the VR is equal to EM sin omega dt is equal to VR sin omega dt, and then the IR, or the current through the circuit, is VR per R. So we can using the like using this equation VR per R sin omega dt, and then we can get that VR per R is IR sin omega dt minus C. And then for resistor, only resistor connect the inductor, the C is equal to 0. So the ER is equal to I big IR sin omega omega dt, because the Z is equal to 0. So for resistive loads, the current and potential difference are in phase. So we can see that the current, the blue line, and the voltage, or the yellow line, has the same phase. The same phase is mean that the initial conditions, or initial sinusoidal, like this one. This is from the 0 is equal between the the current and the voltage. So if we represent in the in the in the Cartesian, this is the phase. So the current and then the voltage is in the phase. In phase means that they peak at the same time. You can see that peak in the same time between both current and voltage have the same peak, and also dip in same time, in similar time. Okay, and then the second, if we connect the alternating current, the capacitor, so we can get the voltage of the capacitor if big VC sin omega dt, and then we can calculate the charge QC is equal to CVC is equal to CVC sin omega dt, and then IC is equal to dQc per dt, so we can get that omega d CVC cosinus omega dt. And if the resistor has the resistance R, and then the capacitor also has a impedance, like the capacitive reactance. Capacitive reactance is the impedance. So we have the impedance. Impedance is Z. Z is equal to we have the R, XC, and then XL. R is the resistive. Resistive is coming from resistor. XC is the capacitive reactance coming from the capacitor, and then the XL is inductor reactance coming from the inductor, and then XC is capacitive reactance of the capacitor. The unit XC is ohm, is like the resistor, because this is the impedance. So impedance also, the units is the ohm. So for the capacitive loads, the current leads the potential difference by 90 degree. Okay, so the current will lead the potential difference by 90 degree, like this one. So this is the current. The current is a green line. He leads the potential difference. The peak of the current will leads by 90 degree rather than the peak of the voltage. So why? Maybe for the logic, and the capacitor store the energy in the electric fields. This means that the capacitor store the energy in the voltage. So because of the energy stored in the voltage, it means that's like the current will be leads the voltage, because the voltage is stored in the capacitor. It's like this one, and then so we can see in this equation, the leads is leads mean that the current peak at the earlier time than the potential difference. So we can see that the current will lead the voltage by 90 degree. So we can get that cosinus omega dt is equal to sin omega dt plus 90 degree. So IC is equal to VC per XC sin omega dt plus 90 degree. So IC is equal to sin omega dt minus C. And VC is equal to IC XC. This is the voltage of the capacitor. And then for the inductive current, the energy or charge stored in the inductor in the current in magnetic field are the currents. So for the inductor, the voltage will lead the currents. So we can see that VL is equal to VL sin omega dt. And then if we make a differential like this one, dIL per dt is equal to VL per L sin omega dt. So the IL is equal to integral DEL. So the constant we make VL per L integral sin omega dt. So we can get that IL is minus VL per omega dL cosinus omega dL, and XL is omega dL. This is like inductive reactance. So the IL is equal to VL per XL sin omega dt minus 90 degree, and IL is equal to IL sin omega dt minus C. And then VL is equal to IL XL. So this is from the inductor. And then the value of the XL or inductive reactance depends on the driving angular frequency or omega d, and then the unit is ohm, is like the XC. So as I before that the inductor stores the charge in the current. So the voltage will lead the current or current lags the potential difference by 90 degree. So we can say that the lags mean that the current peaks at the later time than the potential difference. Or the voltage leads the current in inductor. So we can select this one. So this is the summary. We have the three circuits element, resistor, capacitor, and inductor. The symbol is R, C, and L. And then this is the resistance or the reactance. From R is R, C is XC or capacitive reactance is 1 per omega DC. And then the XL or inductive reactance is omega DL. And then the phase of current, and for resistor in phase, it means that the voltage and current in the same time. And then for the capacitor leads VC by 90 degree. And then for inductor, the current elects VL by 90 degree, and the capacitor is the current leads VC by 90 degree. So the phase constant of inductor is 0, from the capacitor is minus 90 degree, and from the inductor is plus 90 degree. So this is the amplitude relation. VR is equal to IRR, VC is ICXT, and VL is ILXL. So this, if we have a series RLC like this one, so it depends on what is the R and XL and XC. So this is the representing of phasor, representing the alternating current in the RLC circuits. Okay. So this is the VL, this is the VR, and this is the VC. VC is behind I by 90 degree, and then from resistor is in phase, and then from the inductor ahead of I by 90 degree. Okay. Okay, so omega is equal E is equal to Em sin omega dt, and then I is equal to I sin omega dt minus C. So we have to, if we have the question like this one, like we have the series of RLC, we have to check whether what is the XL, XC, and the R. So the first one, okay. So here the Em quadrat is equal to VR quadrat plus VL minus VC quadrat. is equal to I dot R quadrat plus IXL minus IXC quadrats. And then so the I is equal to AM plus square of R quadrat plus XL minus XC quadrats. And then this is the impedance Z. The total impedance is equal to a square of R quadrat plus XL minus XC quadrats. And then the currents, so we have to convert from the XL to omega L. So I is equal to EM per square of R quadrat plus omega dL minus 1 over omega dc. So because the XT is 1 over omega dc, so we can convert expression like this ones. And then from the phase, tan C is equal to VL minus VC per VR, or VL is IXL, VC is IXC per IR. And or the tan C is XL minus XC per R. This is the phase constant. Just like this ones. So the positive C means that the current lacks the EMF or the E, and then it's like this one. So this is the positive C, and then negative means that the currents leads the EMF. So in the graphical of the sinusoid, that's like this ones. This is the voltage is of the current lacks of the voltage, and then this is the current leads the voltage. When the current leads the voltage, so the C, the angle between the negative, and then if the current lags to the EMF, the C, or the angle between the positive, and 0, it means that the current and EMF or E is in phase. If we have the only the R or resistor in the circuit, it must be like this one, because there is no the capacitor and the inductor which can store the energy. And then this is the series of RLC, so we can get this equation. This is the current amplitude of the AC. So it's from this basic equation that the I, or the current, is V per R, and then V is equal to EMF or EM per R, because of we have of three kind of the passive component. So we have to calculate all the impedance of the passive component. So we have R become Z, or the total impedance. So we have a three kind of the impedance: R square plus XL and then XC. And then for the given of resistance, the amplitude maximum when the quantity of omega L minus 1 over omega d Cs is 0. It means that there is no impedance here. So the total impedance of the inductor is capacitor is 0. So we have the maximum amplitude for the R. And then omega dL is equal to 1 over omega dc, and then omega d is equal to 1 per square LC. And then when maximum I occur when the driving angular frequency is matched the natural frequency or at resonance, is like this one. The angular frequency or omega is equal to 1 per square of LC. Okay, this is if we have the resonance, so only the resistor, so we can get like this one. If the R is small, so the current amplitude will be bigger, and then if the R is larger, so the current amplitude will be decreased like this ones. Okay, and then we have the power in alternating current circuits. So the current is or the power is P is equal to I quadrat R here. So I quadrat is equal to I sin omega dt minus C quadrat R. So the I quadrat R sin quadrat omega dt minus C. So the average rates will be like this ones. P average is I quadrat R per 2 or equal to I per square 2 quadrat R. Since the Boltzmann square of the current given by this one, I RMS is equal to 1 over square 2. So the average of P is become I quadrat RMS R, with V RMS also V per square 2, and then E RMS F or EM per square 2. So therefore the IRMS is equal to ERMS per Z. So we change the Z become these equations. ERMS per square R quadrat plus XL minus XC quadrats. So we can using many equation, we average like ERMS per Z PRMS per Z dot ERMS R or ERMS R per Z. So this is the average power. So and then this average power to become ERMS cosinus C. This is the average power, where cosinus V is equal to VR per EM or IR per IZ is equal to R per Z. So if we have the equation about the average power, please using these equations, and then cosinus C also using this equation. And then the last discussion is about the transformers. They can transfer or convert from one AC voltage to another AC voltage, like this one. We have the primary turn and then secondary turn, like these ones. So from the primary turn is connect to the source, and then the secondary turn connect to load, like this one. So the secondary turn is connected to load, and then from the primary turn it will be transferred the flux UB to the secondary turn, and then from the secondary turn they will be transferred the voltage to the load. And then what is the ratio between the voltage and then the turn? We get that Vp per Vs, or the voltage in the primary per voltage in the secondary turn, is equal to primary turn per secondary turn. You can see it, and it's equal to the current in the secondary per current in the primary. So we can get this is transformation of voltage. And then we get that there is no energy loss, so the energy is conserved in the primary on the secondary. So we can, using this equation, this is the power in the primary, and this is the power in the secondary. So IP, the current in the primary, dot Vp is voltage in the primary, is equal to the current in secondary dot the voltage in the secondary. So the IS is equal to IP NP per NS, or IS per IP is equal to NP per NS. And then NIP is equal to 1 over 1 per R, and S per NP quadrat Vp. And then the R equivalent is equal to NP per NS quadrat R. And then the R equivalent is equal to the load resistance seen by generator. Okay, this is the transformer. The transformer can transfer from one side, from primary to secondary. It depends on the turn in the primary. If the turn in primary is larger than secondary, it means that it will be transferred from high voltage to the lower voltage. But if we want to transfer from our voltage to lower voltage to higher voltage, we have to make sure that the turn in the secondary is larger than in primary, like this one. So it transfer the current, or the voltage from the lower voltage in the primary to the higher voltage in the secondary, like this ones. So this is the end of these discussions. Okay, thank you. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.